Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is STL's Deque collection class. Before proceeding, make sure that you have already watched these other videos first. STL provides a collection class that implements a doubly ended queue, also called a Deque. A Deque is an array of values that can dynamically resize in either direction. Some Deque functions are the same as vector functions. These include constructing a new Deque by default construction, initialization from a literal, copy construction, or constructing a new Deque where all of its items have the same value. You can query how many items are currently in a Deque with another function that specifically tests whether or not that size is 0. You can compare two Deques using equality, inequality, and lexicographical comparison operators. A Deque allows random access to its items using either an array indexing operator or the at function. The array indexing operator causes a runtime error if the index is out of range, whereas the at function would throw an exception. The first and last items can be accessed using their special names front and back. For all of these indexing actions, a reference is returned. The erase function removes an iterator specified item from the Deque, but doesn't do any deallocation of it. It can also remove a range of contiguous items, or remove all items. You can call the insert function to insert an item into a Deque. The inserted item does not need to have the exact same item type as the collection, as long as it could be coerced into that type. The insert function will create a compiler temporary to hold the coerced value, and then construct the new item by using a copy constructor from that temporary. The mplace function is a faster alternative to insert. Mplace uses a one-parameter cast constructor to directly construct the new item in the collection. You can use the assignment operator to assign a Deque from another Deque or from a brace enclosed literal value. Another assignment option gives all newly added items the same value. Both assign and resize functions will change the Deque's size to become the requested number of items. The assign function changes the value of all items. The resize function leaves existing items untouched, but possibly cropping some away if there had been too many. Resize only gives this new value, which can default to 0, to those items that are newly added. Unlike a vector, a Deque's internal implementation does not necessarily store items in contiguous memory. Instead, a Deque's storage is a complicated organization of segments of memory. From the user's viewpoint, there is no one single capacity size. Thus, there is no one measurement to be requested by reserve. A Deque's shrink to fit function is more like a defragmentation request. A vector stored its items in contiguous memory, so its item number 4 was guaranteed to be stored immediately following its item number 3. A Deque does allow random access to its items, but you cannot make that same contiguous memory assumption for a Deque. Consequently, a vector's data function, which had provided access to the memory allocation block as a whole, would serve no purpose for a Deque, so it doesn't even exist. Vectors and deques use their iterators the same way as each other. That's true even though a deque's storage isn't necessarily contiguous. This form of iteration still works because STL's internal implementation of a Deque iterator is much more complicated than merely being a memory pointer like it could have been for a vector. A Deque's internal representation might get completely reallocated by any operation which removes any item or which inserts an item into the Deque's interior. Thus, all Deque iterators should be considered invalid after any of those operations are done. Item references and item pointers also would need to be reacquired. If an item is inserted at either end of a Deque, then existing memory will not be touched. Iterators still become invalid, but item references and item pointers are unaffected. Because a vector could efficiently remove and add items to the back of that collection, a vector provided functions popBack and pushBack for doing so, without needing to specify any iterator. There also was an mPlaceBack function, which is a faster version of pushBack, for when the type of the inserted item would need coercion. These three functions are also available for a Deque, but the whole purpose of using a Deque in the first place is that it's also efficient to remove or add items to the front of the Deque. So a Deque also provides functions popFront, pushFront, and mPlaceFront.